Welcome to 3.8. In this lesson we're going to be finding the inverse of a 2x2 matrix. So before we begin, I want you to try these two problems, so pause the video. And hopefully you remember the section before and you got 22 for the determinant of the first matrix and 12 for the determinant of the second matrix. This is going to be important in today's lesson. Okay, now you don't need to write all this down, but a couple of things I do want to note is the identity matrix. It gives an example here of a 2x2 identity and a 3x3 identity. So that's when there's ones along the main diagonal, as you can see, and zeros everywhere else. So the identity matrix kind of acts like the number 1, the same way that when you multiply by 1, you get the same number. So when you multiply by the identity matrix, you're going to get the same matrix. And I know we skipped matrix multiplication, so this may not be clear to you, but that's how an identity matrix got its name. It is the identity, so when you multiply it by a matrix, you get that same matrix back. So what this second paragraph is saying is that if I had two matrices and when I multiplied them, I would get the identity matrix. Again, we haven't talked about matrix multiplication, but just know that two matrices are inverses if when you multiply them, you get the identity matrix. Okay, the other really important thing is this sentence I'm underlining. It says a matrix has an inverse if and only if the determinant is not 0. So that means when we find the determinant of a matrix, and if it's 0, then there will be no inverse for that matrix. If it's not 0, then there should be an inverse, and we're going to learn how to find it. And lastly, the notation of inverse is this, so make sure you have that in your notes. Okay, so the main idea for the inverse of a 2x2 matrix is this. First, we have 1 over the determinant of A. Remember, that's the symbol for determinant of A. So 1 over the determinant times this new matrix. And if you notice, A and D have switched spots from up above. Okay, so flip the positions of A and D. And also, B and C now have opposite signs. So you need to do the opposite sign for B and C, but they stay in the same spot. Okay, so written out a little further, if you remember what the determinant is, it's AD minus CB. So this is going off of the original matrix, so AD minus CB, the original determinant, times our new matrix. And again, we need to be sure that the determinant is not 0 before we can find an inverse. The reason why our determinant can't be 0 is because we would end up with a matrix and all of its elements would be 0. Okay, so let's try an example. So we're looking for A inverse. So the first thing we need to do is find the determinant. So the determinant goes in the bottom of our fraction and 1 goes in the top. So I'm going to have 3 times 5 minus 2 times 8 and now my new matrix, remember I switched the positions of the top left and the bottom right, and I also switched the signs of the top right and the bottom left. Okay, now I'm ready to simplify. So for the determinant I would have 1 over 15 minus 16, which is negative 1. And I still have my matrix here. So now it's just scalar multiplication. So I take -1 times every element in my matrix. And now I've found the inverse of A. Okay, I would like you to try this on your own, so pause the video and good luck. Hopefully you got the same answer as I did. Let's try another one. So pause the video, try this one, good luck. Okay, hopefully you got the same answer as I did. If not, don't worry, we're going to work some more problems tomorrow in class, and come with your questions.